Okay, hello, sorry, I was late. My name is Jiri Olsa, I work for Red Hat, as you heard. Up and down. Okay.
You can use the keyboard or
okay. Okay, so this presentation is about Perf, and Perf actually about the file formats that we use in the Perf, and that's used in the LTTNG, which is CTF. And the overall motivation for this is actually to be able to mix the data from the Perf and with the data from the LTTNG. So what I will go through is I will actually describe the data what we store that we are interested in. I will go in more details for both formats, like the CTF, describe the format for the CTF, and then for the Perf. You will see the comparison between those two formats, and I will actually show you the conversion, the new Perf data convert command that we make that takes the Perf data and convert it to the CTF, and then we can discuss some future implications for this. What data I'm actually talking about, this is the data file. As for Perf, it's the data file that is stored from record command and showed to user by report. This file actually stores the sampling data, and the file format name is perf.data. As for the CTF, this is the file format that is used by LTTNG tracers. It's produced by LTTNG tracers, and there are multiple viewers. I was using the one that goes with the Eclipse as a tracing plugin. What do we actually store in the data files during the tracing and profiling? We are actually interested in events. Events, as you probably know, is some configurable condition in the state, and whenever this condition is hit in the system, we need to store this information to this data file, and the information is stored as the event data, so whatever data can describe the system at the event time, we store to the data file. The events data is accompanied with the system data, which can be various data basically describing the system, like the architecture of the system, the release of the kernel, or other useful information during the report. What is actually the events data that can describe the state of the system? So this is just a subset what we are able to store now in the Perf when the event happens. So from the obvious PID, CPU, and time of the event, we can also store the data for the backtraces, for the branches. We can store the stack, various registers, and all those things can be used later during the report phase for the event. As for the system data, this is the list of the system data that we actually store in the Perf data file. So you can see it's various stuff, different event types needs different data. So for example, for trace point, we store the trace points definitions. We can store the CPU topology, NUMA topology, anything that will be needed during the report. So that's basically what we are interested in to store. It's the event and some other system-related data. I will now briefly, from high-level point, describe CTF and Perf data, and then we will go down on the file format. So CTF stands for Common Trace format. It's very generic format, and it has very nice public specification available for everyone. It comes with the reference library, which actually allows you to read and store the data in the CTF format. And it's very network friendly, meaning that when you store the data, you can actually use the data to be sent over the network. In comparison to Perf data, in the Perf, we are not very generic with the file format we use. We are actually very tightly bound to the Perf syscall kernel interface. We don't have any public specification yet. I'm here to blame for this as well. We don't have any reference library. That's basically the code accessing the file format is not in the library. It's in the Perf code itself. And we are not very network friendly. So how does CTF format looks like? When you get the CTF data, you will actually get the directory. And the directory contains multiple binaries data and one text file. The idea is that the text file, which is called metadata, describes how the binary file looks like. And to do this, the metadata file is actually using TSDL language, which stands for Trace Stream Definition Language. And this language actually allows you to describe the binary data. It's very complex language. It allows you to define any type you're interested in, and it provides you the means to actually define structures that can be used within the binary files. The stream in the TSDL actually means that the CTF forces you to store the data in the streams and allows you to put multiple events definition to the stream. So in overall perspective, you have the tracing data, which is divided to the streams based on whatever condition you like. And for each stream, you can store multiple event types. On the top of it, each stream can be divided into the packets. What TSDL does, it actually provides you the structures for the packet header, packet context, and events in the system, and you can extend those structures and define your own format. So just briefly, how it actually looks like on the left side, you see what's stored in the metadata. On the right side, you can see how the binary file looks like. So the file or the packet, there's actually no distinction on this. It starts like normal format file. You have the magic words, you have the stream IDs. You can actually extend any structures, but those structures that are offered to you by TSDL have some default values which are expected to be there by some existing tracers like Babel Trace, or the Eclipse plugin actually expect some values to be in those structures. So you can actually define whatever you want, but to stay compliant with those existing tools, you need to keep some of the fields inside. So let's go on. This is the packet header, followed by the packet context. You just define the structure of the packet context, and this basically says what is the time range of the data in one packet, what is the size, and various information like if the stream is per CPU, what was the CPU ID, and if there are any discarded events. After the packet context, CTF stores, you define the actual events. So in the binary, you will actually get the data of the events. Each event is defined by its fields. So for each event type, you defined different set of the fields, but you can also have some common fields. Like here, it's the ID and the timestamp is the common field, which is defined in the event header structure, and specific fields for each event are following the common fields. As I said, this is basically one packet definition, meaning this could be like separate file, or this could be used. This binary can be used. This binary data can be used over the network as a packet. So this is the way how CTF can work over the network using the same data as for the file. As for the Perf and the data we store in the Perf, Perf is actually storing the data in one monolithic file. It's not that complex. It's very tightly bounded to the kernel interface. Basically, the data can be divided into following 4 sections. We have some standard header files. We have event. We store the event definitions, and then we store the data. And at the end, we stored something we call features, and which is basically the rest of the system data I was mentioning before. Okay, just briefly, in the header, we store the magic values, the sizes and locations of the events descriptions, and other configuration stuff like what features are stored in the data file. In the header is followed by the event descriptions and event IDs, and here's the place where the file format is basically dependent on the kernel interface. For each event, we actually store the perf event ATTR value, and this is the structure that goes to the syscall. So this is the link. So basically, for each event type, we store in the data file, we store the structure, and we store the IDs of the events. So later on, we can resolve the samples, the data from events. The event descriptions are followed by the data section. The event data is called sample. And here's another place which is very tightly bounded with the kernel. What we actually do when we store the data to the perf, we take whatever kernel gives us as the data, and we store it as a stream to the data file. There are no modifications. So the data start with the perf event header, and whatever you configured in the perf event ATTR structure, those fields are following this header, and this represents the data for one event. After we store all the events, we store the features, which is the various system data I mentioned. So again, this is whatever data can be useful in the report phase, is the ftrace data, build IDs of the binaries we cross, release version, CPU topology, and so on. On this slide, you can see some very high-level comparison of both formats. So as you could probably saw, the CTF on the left side and perf data on the right side. CTF is quite extensible. Well, you still need to keep some default layout to be compliant with existing tools, but you can choose your own layout. On the other side, perf is just specific to the kernel interface, and it's not very extensible. With CTF, you can do the network data streaming. In Perf, you cannot. In CTF, you can actually store the packets as multiple files, which can be handy if you store many data. If you store this in the Perf, you will just get very large data file. And yeah, that's the comparison. As for the CTF, it just, in the directory, you have the binary data and the metadata, that's it. You don't have any extra information. Well, you probably could, but I didn't see it at the current point. You don't get the system data I mentioned. On the other side, Perf is kind of self-contained in this. So in the Perf data, we actually store the build IDs of the binaries. So later on in the report phase, you can actually check those binaries, load them, and resolve the symbol names, and actually work with the data, with the binaries that were running during the capture. Okay, we reached the conversion point. We were so far discussing two ways of converting the Perf data to the CTF. The first one, very obvious, is to read the whole Perf data, and by using the Babel trace library, store the data and create the CTF data. And this is actually what we did. I will come to it in the next slide. The other thing that can be done is actually use the CTF, the TSDL description language, and actually describe the Perf data stream. But it has various implications. The Perf data stream doesn't have this stream layout as CTF expects, so it's tricky and if you do it like this, it couldn't be read by existing tools like Babel trace. Okay, so what we actually did was the conversion events one by one. Me and Sebastian wrote the Perf data convert, and it actually does the number one option I described. It reads the Perf data, it parses it, take each and every event and store it to the CTF. So here in this example, you can see this is how we compile. You need to provide the Babel trace library, then store some data, and using the Perf data convert to CTF, you will get the CTF data. You will get the CTF directory, which will contain metadata and binary data. And just briefly, we actually follow the default layout, the default CTF layout, so the data that we actually store can be read after by the Babel trace and the Eclipse plugin. So this is data I described before. As for the events, we store ID and the timestamp as a global point for each event, and after we store specific information for each event. So you just define the fields, like here for the hardware event, or we actually, if you store trace point, we actually parse the trace point data and store the trace point data as separate fields. So this is the layout of the schedule switch trace point that you will get in the CTF after the conversion. The drawbacks of this offered so far, we don't have any symbol resolving. As I said, in the Perf, the resolving of the symbol is done in the report phase. We read the binaries, give the address, get the symbol back, and display to the user. But with the CTF, we actually don't have any such binaries attached, so we actually need to resolve those symbols when we store the data, but we are not doing this so far. And we don't store call chains at this precise moment. As for the future, well, so the current state of this conversion is that we send out the RFC to the upstream. We didn't have any, we didn't have much response, but I believe the global idea, the future for this would be actually to mix the data with the Perf and LTTNG tracers, and well, provide the overall report from mixed report from both Perf and probably LTTNG plugin or other guys that's using the CTF file format. Okay, that's probably it from me. If you have any questions.
Hey, so what is the performance of your Perf data to CTF conversion?
Right, so as I said, it's the RFC, so we actually didn't measure anything.
You got feeling megabytes per second, gigabytes per second, kilobytes per second.
Yeah, I think it was pretty fast. We actually didn't measure anything because there wasn't much space for actually making it faster. As I said, we take event by event and convert it. You need to load the event and store the event in the CTF manner. So it takes some time, but it was fast. Yeah, we didn't try actually any benchmarks. So we are at this point we are basically waiting for some feedbacks if we want to continue this way, and what's the feeling about this.
One of the cool features of Perf is that it allows to get the call stack of user space processes. How do you see we can integrate that into CTF? I mean, the whole chain with build IDs and so on, in Eclipse, for instance.
Yeah, so in the Perf, we store the call chain as the array of the pointers. Well, that's for the kernel, and also for the user space. As I said, we don't have the support now, but the support is probably just to take this data, this array of the pointers, and put it as another array to the event data. It's a little bit tricky because in Perf you can have two kinds of call chains. You can either work the frame pointers, and then you will have the array of the pointers, which could be probably easily stored in the CTF. But now we have also the other way, which is the dwarf unwind. And for the dwarf, you actually, for each event, you need to store the user space stack, and you need to store the state of the registers. So you would need to make some structures in the event to actually store this. And the implication also is that when we actually unwind those dwarf data in the report phase, so, and we need to touch the binaries, which are not part of the CTF, so it's another issue I can see. But yeah, generally it will be probably possible, but needs more work.
So from the CTF side, well, it might be possible to look into using the type system in TSDL to basically describe some of those pointers and specify, oh well, this pointer is basically mapped to a specific binary file or a specific mapping, so that we can then do a lookup. So this is something we could extend the specification to support something like that. So that might be interesting. And I was actually curious about the file size. In the conversion that you showed, the Perf file, perhaps because it contains some meta information or some padding, seems to be quite larger, so 0.013 megabyte, and the converted file is quite smaller in CTF and appears to have, so the first one is an approximation of samples and it's around 500, and the other one is 21. I'm actually curious on the reason for the difference.
Yeah, I'm curious as well. Yeah, I think we actually, this number as far as the record goes, it's some estimation, because as I said, what we store from the kernel is just the stream, and we have some estimated size of the event, and we take the size of the stream, divide size of the event, and that's the number we print. So probably we did the same measure here. Yeah, needs to be fixed. As I said, it's RFC.
So I wonder if there's any intent to make CTF self-contained, in the sense that you have symbols in place and not references to families.
Yeah. Well, I'm not aware. Well, not at this point, right? We probably will be here discussing these things. Not at this point, as far as I know. But if there's a will, there's a way.
So Intel recently released some patches to support their hardware processor trace feature in Perf. Have you looked at what it would take to convert that to CTF?
Well, I just saw briefly those patches, and I think they are still using the Perf data file to store them, right? So in the standard way. So whatever goes to the Perf data file, I think we will be able to convert. But as I said, I didn't see much that Pact said maybe they are adding some more data. I'm actually not sure.
All right, so has there been any discussions or thoughts on the future in terms of actually making Perf into a LTTNG producer, so that you would get all the LTTNG infrastructure for free, more or less? So for instance, getting Perf events through the relay daemon and so on.
Well, at the moment, we discuss only those two options. So first you take the file and convert it to the CTF file, and the option you're probably talking about is actually to be able to stream the data from the Perf record directly to some LTTNG consumer. And that's probably more or less the option number 2. So if we were able to create such a CTF description that would describe the Perf stream, Perf kernel stream, which goes from the kernel, and store it to the data file, that would be probably, that would be it. Then we could stream this data out to the network, to whatever consumer. But at the moment, as I said, I'm not sure how to do this with the CTF. We need to discuss this option.
So, like during our debugging, we've noticed that Perf is kind of quite intrusive, and in certain performance-related test cases, we were not able to recreate the issue when using Perf. Like when we enable Perf, we are able to correct the data, but the problem kind of disappears, and it actually slows down. It's because that it kind of slows down the system considerably. So with this CTF, like what I can see is that you're collecting the Perf data, but then finally the data file that you're creating, it's kind of much more lightweight as compared to the Perf data. So would it make sense that we kind of integrate it in such a manner that we are getting the CTF format, or I mean, we are kind of doing a bit more lightweight monitoring, I mean, for the CTF file. So that would make it a better tool for performance specific test cases.
Mm-hmm. Well, as for the performance, I don't think the Perf data itself is that bad. I think, well, basically, when we store the data, we take whatever kernel give us, and store it to the file. There's no like extra work. So I don't think that by using CTF we will gain more speed to the perf storage, but we will get more configurability, more versatility. That's the point here. Probably we will not gain more speed. Maybe if we will be able to actually describe the data from the kernel with the CTF and don't store it to the file but stream it to directly to the network, maybe that would be it. That would have some performance benefits, not to store file, but to send it over the network.
Actually, one thing we could try out is, since Perf ring buffer is basically tailored for accessing the samples very quickly without any system calls and things like that. So we have that on one side. We have ring buffers for high-speed tracing, such as the one in ftrace, LTTNG also. So, I mean, for really the performance-sensitive use cases where a lot of samples needs to be extracted, then it appears that it's more like the high-speed tracing scenario than the let's collect one sample every second scenario. Mm-hmm. So in that case, perhaps binding perf onto either ftrace or LTTNG ring buffers, and well, with LTTNG you could actually extract in CTF natively. So that might be actually something to try out, and perhaps have an option so that it can be either the perf buffer for kind of memory map based low sample rate scenario, and then high speed tracers, perhaps.
Yeah, that makes sense. Okay, one last question. I scared you. Thanks, Jiri.